Here we have a geometry problem. Okay, let's go to the question. In the circle above, O is the center. Find the value of x. Okay, here we have x in this circle. We have to find the value of x over here. Okay, now let's plan how to find the value of x. Let's consider the quadrilateral ABOC. So because it contains four sides, 1, 2, 3, 4. So since ABOC, the polygon contains four sides, it's a quadrilateral. And let's consider the four interior angles of this polygon. So this is one interior angle, and let's say this is second one, and this is the third interior angle, and this is the fourth interior angle. Okay, when I add these four interior angles, it must be equal to 360 degree. In any quadrilateral, the sum of the four interior angles equals to 360 degree. Okay, in these four interior angles, already I know the measures of the two interior angles over here, x and 20 degree. So once I get this interior angle and this interior angle, I can add all the four interior angles and it will be 360 degree, and I can solve for x from that equation. Okay, now my aim is to get the angle measure over here and angle measure over here. Okay, first let's consider the angle measure we have over here. Actually, this is the angle subtended by the arc BAC. So this is the angle subtended by the arc BAC at the center of the circle. So there is a theorem in geometry, that is the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at any point of the circle. Let's consider this angle measure 120 degree. Actually, the angle at the point D on the circle is subtended by the same arc, that is BAC. So now the angle subtended by the arc BAC at the center must be 2 times this angle 120 degree, which is subtended by the same arc BAC at a point D on the circle. So what is 2 times of this 120 degree? 2 times of 120 degree is 240 degree. Okay, now in the four interior angles of the quadrilateral ABOC, I have 3, x, 240 degree, 20 degree. I need to find one more angle, so that's over here. Let me assume the angle measure over here is y. Okay, now let's consider the angle subtended by the arc BDC at the center. So this is the angle subtended by the arc BDC. So what must be the angle measure over here? It has to be twice the angle subtended by the same arc BDC at any point on the circle. Okay, now let's consider the angle y over here. So this angle is subtended by the same arc BDC at a point A on the circle. Then what must be the angle subtended by the arc BDC at the center? It has to be twice this angle, that is 2 times y, 2y. Okay, now when I consider the angle over here, this is full rotation. Already we know that the measure of an angle which has full rotation is 360 degree. This 2y and this 240 together form an angle of full rotation. So this 2y and 240 must add up to 360. Okay, now let's solve for y in this one. So for that I subtract 240 from both sides. When I subtract 240 from both sides, so the positive 240, negative 240 will cancel out. I'm getting 2y on the left side. When I subtract 240 from 360, I'm getting 120. So to solve for y, I divide both sides by 2. This 2 will cancel out. Then y equals to, when I divide 120 by 2, I'm getting 60. So now I got the angle measure over here at A. So that is 60 degree. So because already I have assumed this angle measure is y, but now I got the value of y, that is 60 degree. Okay, now I have all the four interior angles of the quadrilateral ABOC. So now if I add these four interior angles, 60, x, 240 degree and 20 degree. So they all will add up to 360 degree, because the sum of the four angles in any quadrilateral equals to 360 degree. Okay, let me add it. So first let me take x, and then I'm taking 240, then I'm taking 20, then I'm taking 60. So I have added all the four interior angles of the quadrilateral ABOC. So it must be equals to 360. Okay, x positive. So when I combine 240, 60 and 20, I'm getting 320 equals to 360. Okay, now to solve for x, I subtract 320 from both sides. When I subtract 320 from both sides, I'm getting x equals to 40. So the value of x in the given circle is 40.